Okay, so it says a big satellite dish measures 8 feet across, and then it also measures 1.5 feet deep. Okay, this is obviously going to be a parabolic shape. Okay, and what it is this satellite dish will receive waves, if you will. Like it'll receive signals, and it will bounce off, and it will hit this receiver, which will then go hardwired to like your TV and give you, I don't know, cable or whatever. Okay, so that's what the job of this parabola is. So we're going to say that part A, it's a parabolic shape for sure. Let's go to part B. We want to determine the distance d that this receiver that we talked about before be placed from the vertex. So this distance d from the vertex would be this right here. How far should it be in order to maximize reception so that you don't get static, so that you don't get any lag per se in the signal that you're getting through this satellite? We want to make sure that we place it in the most opportune spot. Okay, this is a parabolic shape, so we know it's going to be 4 AP classes equals 1 tough year. And that distance that we're talking about is, in fact, P. Okay, so that distance is correlating to that P value that we know from our equation with parabolas. Okay, so we know that this is also going to be some type of vertical parabola. So it'll be a y equals ax squared kind of interpretation, if you will. And I want to go ahead and make this vertex my origin. Okay, so that vertex is very important because we need to first find this. So then we can see how far away from that vertex do we need to put the receiver. Okay, so if the vertex is 0, 0, and we have y is equal to ax minus h squared plus k as my standard form, then I know I'm going to put this 0 here for my x value, and I'm going to put this 0 here for my y value. And now we know a is positive because it's facing up. We have something that looks like this. Y is equal to ax squared. Okay? Now, we either need to know a to find p, or we need to know p to find a. Okay? So what I have here is not straightforward just given to me. So y equals ax squared. We don't have this a term. We can, however, use a point on this parabola. Let me highlight this in blue. This parabola would lie here. Okay? And we can use any point on this parabola, and I'm going to choose to use this one right here. Because I know x-wise, I needed to travel 4 feet, because that's half of this entire 8 feet diameter that they gave us. And then I needed to go up 1.5. So this point right here is in fact 4, 1.5. Okay? So I'm going to use 4 for my x value here. And I'm going to use 1.5 for my y value here. This will allow me the opportunity to find what a is. So 4 squared is 16. Therefore, get a by itself. It'll be 1.5 divided by 16. And let's see what we get with the calculator. If we do 1.5 divided by 16, we get this weird decimal number. Okay, if you were to put this into your calculator, you would get something like a is equal to 0.09375. Okay? Alright, so 0.9375 is a that I now get to use to find p. So we'll say 4 times 0.09375. Now I did say to use 6 decimals, but unfortunately this number does not produce 6 decimals. So now I'm just going to use this to find p. So 4 times this, and I'm going to move it over so that p is equal to whatever 1 over 4 times 0.09375 is equal to. Okay, so let's go ahead and go to the calculator. We're going to go ahead and plug this in as we see it. Okay, so go to the calculator. We have control divide 1 over 4 times, and then 0.09375. Whenever I do control enter, I get this. We're going to round this to 3 decimal places the way we've been doing everything else, so that my p-value is in fact 2.667. And what do we have? Feet. So we're going to say feet. Again, this is the length from the vertex up to the receiver, and you would answer this as far as the receiver should be placed 2.667 feet from the vertex. So you would actually write that out in words.